Hi, I'm Dan Swearingen with Autistry Studios. In part one of these videos, we showed you the Arduino and the different formats that you can get the Arduino microcontroller in. In this video, part two, Dan Coppock will be showing me different robots that he has made with the Arduino microcontroller. And these are great introductory projects for people wanting to learn how to use the Arduino to control projects. And this is Dan Coppock, who's been working with us, and I assigned him earlier in the summer to learn Arduinos, and Dan went nuts on it.
Not the first time I've done that.
So which one would you like to show off first?
We'll start with the first.
Okay.
So the first one I built is this here. It's got a nickname Jack. When I first built it, it was fairly slow. It did work well, but it was not much fun to watch. So we upped the battery voltage considerably, which makes it very quick and acts like a Jack Russell Terrier, which hence its nickname. It actually burns rubber when it changes direction.
So yeah, these are what are called, if you Google Arduino two-wheel drive or 2WD, you'll come up with these, and it's a pretty standard pattern. It's been traded around freely in China, and so there's probably 20 different people making kits of these. Mm-hmm. They all have the same basic materials in them. Mm-hmm. You have an Arduino board. Go ahead and hold it up close to the camera. So there's an Arduino board underneath, and then there's basically a board with controlled pinouts for putting all your components plugged into, and a power regulator right here.
Right. Motors are hooked to the power regulator directly.
Right. Then the other standard piece is the ultrasonic sensor. And you'll notice that virtually every robot on this table has that same ultrasonic sensor. It's an extremely standard thing. Even this little...
Yeah, I should turn it that way. The cat.
Yeah, the cat.
Everything.
Everything. And it's just a very inexpensive ultrasonic rangefinder that plugs in. With the two-wheel drive robots, what the whole project is really about is getting it to respond. If we put obstacles all around the table, we should be able to drive Jack, and Jack should not drive off onto the floor. Can you turn Jack on? Oh, very good.
I put bumpers on it for a reason, because
That's great. Then the other fun thing to do is once you have a fleet of these is to get them to do swarm behavior. So, and that would involve them being able to somehow see each other. Typically what people do is they'll put an infrared LED on the car, and then they'll add to the ultrasonic sensor, they'll add an infrared detector. So it can sweep around and it can see the other cars because it can see the infrared light that's on them. And then what you can do is you can get them to do things like follow each other.
one of these is supposed to trail. That one, I think, has a trail mode.
Has a trail. This one is really fascinating. Why don't you talk about that one?
Yeah, this one is a four-wheel drive vehicle. Hold it upside down. So you get four motors there. What is interesting is these wheels all have rollers on them that are loose in the wheel. So depending on which way you drive the wheels, it'll roll forward, backward. It'll run at a 45-degree angle or straight sideways.
Wow.
So, and you can spin it around, it'll spin in a circle.
And you can see that it's got two of the power regulator boards, one for each pair of motors, I guess.
Right. Yeah.
Okay, and then this device here, that's is that a Bluetooth communicator?
Yeah, that's a Bluetooth.
Okay.
So you operate it with your phone.
So several of the cars, so for instance, yeah, this one's got a Bluetooth board in it. So there's a bunch of standard components that come with all of these. The reason I have these up here is that these are, looks like two different kinds of Arduino starter packs. Here, this one's opened. And this is a recommended starting point. And it's basically a bunch of components. See, there's a bunch of wires. Yeah. ribbon cable, so you basically tear these off for wires. And perf board, that one must have the actual Arduino in it. Yep. And of course, once we've done this, we'll never get it back in this box again.
No.
All very
So we
carefully
can get
packed.
the box open.
Yeah. Now, as I'll say before, this is the actual Arduino microcontroller. The Arduino is not the best microcontroller out there. However, what makes it useful is that there's a whole ecosystem of things that work with it. And that's where it becomes valuable, so that once a student learns how to program an Arduino, and then we're just wrapping more and more complicated things around it. This thing, which is still a work in progress that we need to work on, so it's in the form of a cat. And this is actually Arduino compatible. And in the sense that it can be programmed with Arduino software, and the software feels like it's an Arduino, but they've actually come up with a custom PC board for it. And as Dan was pointing out, as he tried to construct this, it's not at all clear how you actually thread the wiring for all the different servos.
Yes, the upper servos here have very short wires on them, only some of which will actually meet on the circuit board where they're supposed to. So then they provide longer wire ones down here at the elbows, or whatever you want to call them. And they have longer wires, but they're not long enough to meet. So there's some difficulties with it. It's cute, but
Yeah.
it's still being a work in progress.
And what I may do is, these servos are standard units, and what I may do is just look for servos that have really long leads on them.
Well, actually, I ordered some, but they were too large.
Okay.
I got some really big servos now.
Right. Yeah, so those were probably called micro
Yeah.
servos. Yeah, then these are mini micros or something.
Well, what I was planning on doing is getting some longer wires and putting these up here,
Mm-hmm.
because then their wires would be long enough.
Yeah.
But
So this was a Kickstarter campaign, and the videos for it were so attractive. I just bought it. I bought 2 of them actually, and the idea is that you can give it cat-like behaviors, and it's in the form of a cat, so it's kind of cute.
yeah.
And out here. But the idea is that we'll get students started with the Arduino kits, but eventually, of course, the students, what their goals are. God, tell me about this one.
Okay. This one is 6-legged. The software needs some help. All it does is it moves them fore and aft, when what it needs to actually do is pick them up, move them, set them down. So I need to do some software configuration.
Right.
But it's 6 articulated legs. It will look around also, or you can drive it from your phone also.
Wow. So yeah, and so coming up with kind of a complex behavior, what you would do is figure out what the movement is, and then be able to just call that movement. You know, and so that would be a pick up and move leg forward, and there'd be a pick up and move leg backward, and yeah. Then Dan, you got a 4-wheeled one.
Yeah. This has got the same motors as the 2-wheel drive.
Yeah. Go ahead and look at the monitor, and then you can see where you're at.
Yeah, this has the same motors as the 2-wheel drive one, except 4. It is a 4-wheel drive. Will give you a readout of voltage is primarily which way. You can run it with your phone. You can run it with an infrared remote control, which is somewhere there. It's one of these.
Is this one?
It's that one, I think. So it has a remote control, or you can operate it from your phone.
I see you've got a bumper on this one too.
Yeah, mainly because Jack was running into it. So I was protecting this car from Jack. It doesn't move as fast where it was running in and sliding, because Jack slides into objects.
Right.
Doesn't run into them. So.
And the eventual goal of this exercise is to actually make robots that can have pretty complex behavior. I know the kitty cat is actually designed to be able to put a Raspberry Pi computer on the back of this, and then the Raspberry Pi can then drive this thing, and the Raspberry Pi computer can run more complex software. The Arduinos are great, but at a certain point you run out of, if you want like really complex logic, the Arduinos just don't have enough really memory and computing power to handle that.
Well, that's why this one actually has, show you on the side, this is the tank. We'll start out as a tank. So it just has two motors. Let me break it down though. It has two motors only, which drive the two tracks. This, the way I configured this one, it actually has two Arduinos. It has one to run the tank and one to run the arm in the back.
Got it.
Which is controlled by the joysticks here.
Right.
So it's actually two completely different computers, partly because of my inability to program them really well.
Mm-hmm.
You get one to do both.
I don't think you could get one to do both. And really, at a certain point, you go, okay, that's where you stick a Raspberry Pi on it.
Right.
The Raspberry Pi can basically send commands to those two. And then those two can be much more simple.
Mm-hmm.
Really, the job of the Arduinos at that point would be to take like the data from the ultrasonic sensor and deliver it as a number up to the Raspberry Pi, and the Raspberry Pi would do logic on it and then say, okay, motor B needs to go faster, and things like that. Mm-hmm. And so it's what you would then do is program the Raspberry Pis to accept, or the Arduinos to accept kind of high-level commands coming down from either your remote controller or the Raspberry Pi. You can do it. All right, this is awesome. Please feel free to leave any comments below. In part 3 of this video series, what we'll be showing you is actually how these robots operate and various design considerations when you're programming and building these robots. Thank you.